Welcome back, guys. Welcome to Xerox Hack. I have Aidan with me. Hi, Aidan.
Hey everyone.
I'm very glad to have you. Aidan is working on Snowbridge, which is a bridge between Ethereum and Polkadot, created by Snowfork, which is a group of developers, designers, and researchers and product managers. And yeah, Aidan will tell you more about the Snowbridge product. So without further ado, Aidan, the stage is yours.
Cool. Hey everyone. So I'm Aidan and I'm from Snowfork. I just wanted to confirm that my presentation is being shared. Yep. So as mentioned, Snowfork is a collective of designers, product managers, researchers, and developers that work together on different projects. And one of our main focuses for the last year or two has been interoperability in the blockchain space. And that's this main project that I'm going to be talking about in this presentation is Snowbridge, which is a bridge between Polkadot and Ethereum. I'm also going to talk a bit about layer 2 and bridging in general, because I think our bridge sits in an interesting place within the wider ecosystem. And then there'll be some more info at the end if anyone's interested in looking more into the products, looking into using the bridge, and looking into more about Snowfork in general. So yeah, let's get started. So Snowbridge. So one thing when it comes to interoperability in the blockchain space is there's often a trade-off between trust, cost, and user experiences. And some of these trade-offs are kind of in some ways theoretical. Some of the trade-offs are due to the kind of just progress of where the space has evolved today and what systems are out there. And some of these trade-offs will be kind of solved, I think, in the coming months and years. But at the moment, if you look at the various interoperability, layer 2, sidechain style solutions, there are these trade-offs. And in some ways that's good because there's different kind of products built on our blockchain with different use cases, and they will want different trade-offs. Some different projects have different kind of trust characteristics. Maybe for some projects, the trust and availability is far more important. For other projects, only just trust and correctness is sufficient, and censorship resistance is not as important. And so the trade-offs and kind of the range of different interoperability solutions that's emerging is a good thing because it allows applications to really pick the kind of trade-offs between trust, cost, and user experiences that they may need. And so similarly for our bridge, we have kind of a place within these trade-offs that kind of trades off between decentralization and trust. And so when it comes to bridges, you often see like plasma bridges and proof of stake bridges, which have a certain amount of stakers that are guaranteeing the security of the system, as well as kind of more cryptographic based bridges. And so in our system, we are currently have a kind of longer term focus where we believe the core target for crypto and the ecosystem is focused on trust minimization. And so what I mean by that is really users should need to trust people, teams, projects as little as possible, and all of their trust should be fully transparent and fully verifiable just by looking at the code and the cryptography used in the solution that's made. And so the way our bridge achieves this is using various cryptographic and like mechanisms that I'll get into later. And I think when you're thinking about interoperability and layer 2 solutions in general, you can compare them based on what kind of mechanism they use to guarantee trust of their system, whether it is something like trusting in a set of validators or trusting in their stake that can be slashed, or just trusting in kind of a Lifelines or a cryptographic proof. The other aspect to our bridge is that it's intentioned to be general purpose. So token transfer is the most common thing that people think about when they think about blockchain interoperability, whether it's Ethereum itself in this case, or ERC20 tokens or other assets. And then general asset transfer for things like NFTs. But our goal is also to kind of have a general purpose bridge which allows for cross-chain arbitrary data, hybrid cross-chain applications, and essentially cross-chain function calls to the point where you can write kind of a piece of business logic or smart contract on one chain and call a function directly on another chain, irrespective of whether that function has anything to do with asset transfer or financial transfer. And so the kind of benefits of bringing a more powerful general purpose chain is that it can be used for more than just kind of moving assets to different ecosystems. I think the core purpose that we'll see initially is people moving their assets across different ecosystems and interacting with the different things on other ecosystems. But with a general purpose bridge, you unlock other kinds of things like using Polkadot as a kind of sidechain to Ethereum. And so you can kind of scale performance, you can widen kind of the communities and share communities between Polkadot and Ethereum, and you can support existing Ethereum apps to expand into the Polkadot ecosystem in a way that is native to them, where they can potentially even run some of their software on Polkadot or share some of the, for example, liquidity users and state of their system across both chains. So I'm going to now dig into a bit more details about our trust mechanism and our architecture and how we manage to guarantee all of these things. So first of all, specifically, when it comes to trust minimization, the main mechanism we're using is Lifeline verification. If you're not familiar with Lifelines, Lifelines is a kind of client of a blockchain that, instead of having to do a lot of hard work in progressing the consensus and downloading large amounts of data and doing large amounts of computation, it can do this with a much more minimal resource requirements. And so in the case of like Ethereum, you've got Ethereum full nodes that go and run miners and kind of run the full state transition of every block. But you also get Ethereum Lifelines, which can run on almost any device, and they don't verify like every single part of the state of transition of every block, but they can verify specific parts of the state or specific transactions in a way that is very much guaranteed and almost the same level of trust as if you were running a full Ethereum node. And so similarly for Polkadot, there's a similar kind of lifeline that we've built that allows us to do that. So in practice, this comes into two things. There's an Ethereum Lifeline palette. So this is a specific piece, a module in Polkadot. The word palette, it kind of refers to a module or a smart contract, and in some way where you place your business logic that runs on your chain. There's different ways to do it, but we've developed a Lifeline within a Polkadot palette, which is a Rust library. And what it does is it follows the latest Ethereum headers. It checks the full proof of work on chain on Polkadot to verify that we are following the heaviest chain. And then it can accept events from Ethereum. And so whenever kind of a smart contract on Ethereum generates events, this palette can interpret those events and verify that they're part of the heaviest chain, and so verify that they are really in Ethereum based on Ethereum's protocol. And so this runs on Polkadot, on our parachain on chain, and so essentially allows our chain to verify any state from Ethereum that has come in recent blocks. Then we've got Polkadot Lifeline, and so this is a set of smart contracts that we've developed that allow us to verify Polkadot behavior. And so this is slightly more complicated because in the case of Polkadot, instead of having just one blockchain, you've got many different blockchains and many parachains. And so in the case of our bridge, for example, we are running our own chain, which is the parachain of Polkadot, but there's also the main Polkadot chain. It's a little bit analogous to Ethereum 2.0, where you've got a main kind of the main chain as well as the different shards. And so essentially we need a Lifeline not just for our parachain, but also for the main Polkadot chain. And so we've actually got kind of two Lifelines bundled in to our set of smart contracts. So what happens is our first Lifeline follows the main finalized Polkadot chain. And so essentially Polkadot's proof of stake. And so as new signatures are produced to create new blocks, Polkadot's chain progresses, and our Lifeline is similarly capable of interpreting those signatures. It can check the full logic of the proof of stake on chain, and so follow Polkadot's consensus. And then within Polkadot's consensus, Polkadot also attests to our chain, our parachain's blocks. And so then we have a similar Lifeline for our parachain that can look at those blocks and verify events within our parachain. For example, messages being sent across the bridge or assets being sent across the bridge, and verify them dead on Ethereum. And so essentially both of these components run fully on chain. And so there's no kind of human or validator really involved in this, and the Lifeline can happen, verification can happen fully on chain. But one thing I've talked about is, these Lifelines can follow Ethereum. So how does Polkadot follow Ethereum? How does Ethereum follow Polkadot? There does still need to be some component in the middle that relays messages between Polkadot and Ethereum. But this component is not trusted. Really, it's fully permissionless. Anyone can run this component. Like even an individual user that wants to relay a single message themselves can run this themselves. And so there's no kind of need for an intermediary to control what gets relayed across. Yeah, and so let me talk a bit more next about the incentives and guarantees that our bridge happens to provide. So yeah, as I mentioned, there's this relayer. And so this relay is fully trustless and permissionless. Anyone can join, anyone can relay. And so we imagine we will be running kind of a community of relays that for kind of nice user experience and kind of for the everyday user provide services of relaying for anyone's messages. But any user can just run it and relay themselves if they just don't want to trust anyone else or they don't want to pay anyone else, and they can relay their own messages themselves. Longer term, I can imagine us even kind of automating this for end users into something like a front end, and so essentially have the front end even doing relaying. And so like the capability to become permissionless, not in just our protocol, but even in our UX, I think is something we can achieve longer term. Having said that, the kind of there are some rewards and incentives to incentivize high quality service and to improve the user experience through trust. And so there will be a process by which people can run relayers to earn kind of extra fees and incentives if they provide good UX for their relaying. And one thing to keep in mind is these incentives are kind of extra. They're not core to the protocol. They could be done for a nonprofit. They could be done for businesses that's relaying. It could be a kind of permissionless tokenized network. But the base protocol is permissionless and anyone can relay. Then if you look at the Polkadot side of things, where there's a parachain correlator nodes and Polkadot, we also aim to be permissionless in our parachain and the correlated nodes that run on our parachain. There's still some challenges here in terms of how Polkadot works with its parachain verification, but that has matured a lot in the last few months. And so we will soon be able to, I think, run a parachain in a permissionless way. And essentially the rewards and incentives to run a correlator node may depend on sub-permissioning. But if you look at the security of the bridge as a whole, it's essentially the security of Polkadot and Snowbridge combined as if it was a sidechain to Ethereum. And so with kind of sidechains and bridges like this in general, the security of the system as a whole is usually the kind of minimum security of Polkadot and Ethereum. So in this case, Ethereum has a certain amount of economic security and kind of consensus-based security, based security, and Polkadot has the same. So yeah, next I'll talk about where we're at today, our progress, and the roadmap, and how people can kind of get involved if they're interested. So yeah, I'm going to run through some example usage of our bridge. So first, in the case of sending messages from Polkadot to Ethereum, one thing kind of I didn't mention yet is our bridge has a kind of layered architecture. And so there's the lower level functionality of the kind of general purpose bridge, but on top of that, we support applications that anyone can build. And so anyone can hook their applications into the bridge to send messages back and forth between Polkadot and Ethereum. And so in this example, I'm going to look at one specific application that we've developed, which is the kind of dot application. And the purpose of this application is really for asset transfer of dot itself. And so users can go and lock up dots on Polkadot, and then that dot will get transferred and minted on Ethereum into an ERC20 token. Similarly, if people want to send their assets back, they can burn the ERC20 token on Ethereum and return it back to Polkadot. And so it's a basic kind of asset transfer application specifically focused on dots. So it's like a fairly simple application. It has a small component on the Polkadot side, a small component on the Ethereum side, but it's built at kind of a higher level application layer, and it interacts with our bridge. And so most of that is abstracted away. So the first thing you can see in this example, I mentioned that how kind of external users will interact with this application is they send a transaction to Polkadot and to our parachain, which locks up dot. And so this code is kind of Rust code, which is how conventionally a lot of logic on Polkadot is written. It doesn't always have to be in Rust. For example, you may have seen earlier, there was a presentation by a team called Moonbeam that allows you to write smart contracts in Solidity to run a Polkadot. But this is an example with Rust. And so the lock function is really an extrinsic transaction that is sent to the chain with a channel ID, a recipient, and an amount. And so essentially, when people lock up their dot, they call this function. This function will kind of take their dot and lock it up within this module. And then it submits this lock event across the bridge to be interpreted by the Ethereum side. And so if we dig into this and look how it works internally, you can see, first, let's look at what's happening on the Ethereum side. So this is our Solidity side of the contract. Each application has like a Solidity component and a kind of that runs on Ethereum, and a component that runs on Polkadot that can be in any language Polkadot supports, which in this case is Rust. But if we focus on the Solidity side, it's very minimal. You can see there's a mint function that will be called, and this will kind of mint the new dot to the end user. And so the Solidity side is expecting this mint function to be called. And so what happens is when this lock transaction runs, if we go now and look internally, there is a kind of lock call that happens over here on these lines, where we are essentially creating this message, which is a payload that's going to get relayed across to the Ethereum side. And so if we look at the payload in this file, you can see this payload is really encoding a Solidity call. Here's kind of the key if you kind of are getting confused with a lot of what I've been saying. Specifically here, you can see we're encoding a function call to the mint function, which has 3 parameters. These are the 3 parameters that we're expecting on the Solidity side of the sender, the recipient, and the amount. And this application is essentially calling the mint function on the smart contract across the bridge. And then that gets relayed across the bridge, and when it's delivered, this mint function is called and the token is minted. You can see we're still kind of finalizing some of the checks and verifications here. But that's kind of essentially how applications interact with the bridge. They kind of encode a function call to the kind of in the Polkadot to Ethereum direction to a Solidity function, and then they submit that function call into the bridge, and the bridge handles the rest. And essentially, then the function gets called on the other side. We're planning to probably improve this in future. As you can see, when it comes to kind of calling the function, there's a little bit of manual work in here, having to kind of encode the function and convert the types from Rust into what Solidity expects. But we'll be introducing probably some improved syntax and APIs for that. If we go and look at things from the Ethereum to Polkadot direction, now we've got essentially the starting point is when the user is coming to burn their dot. So they would call this function call with the recipient amount and the channel ID. I'll talk about channels later. And they burn their ERC20 token dot. That causes a burn in the ERC20 contract. And again, this encodes a call and submits that call into the bridge. When I say encode call, what does this actually mean? You can see, let's kind of dig in here. So really what we're trying to do is call something on the Polkadot side. So if I go and look back at our Polkadot application, there's this unlock transaction. And so the unlock transaction is really what the bridge is calling to go and unlock the dot from the bridge and return it to the user. And so the unlock transaction, it takes a sender, a recipient, and an amount as its arguments. And so if you look on the Solidity side, we're encoding here the sender, the recipient, and the amount, and the unlock call, which is kind of the index of the actual function call on the Polkadot side. And so this encoding really encodes a call to our parachain, to this Rust palette, the module in Polkadot, and is essentially encoding a call to a transaction. And so essentially what's happening here, again, is this application on Solidity is doing a direct function call into this palette on Polkadot. This is kind of the example that I'm showing in this application, but you can imagine for other applications, for example, if there's an application running in Solidity on Polkadot, we could enable a kind of much simpler function call where we do an actual kind of Solidity encoded call that looks very similar to when you're calling a smart contract on Ethereum. And so we essentially want the developer experience to be such that whether you're calling a smart contract on Ethereum or calling a smart contract on Polkadot, the syntax and the interface is very minimal and very similar. Obviously, the main difference is there's an asynchronous element to the latter, calling on Polkadot, but the interface and the integration is very similar. And so to close this off, if we go and look at the unlock function call on the Polkadot side of things, this is the unlock function, and you can see here is where the dot gets unlocked and sent and returned to the recipient. Yeah, and so that's kind of the high-level functionality of how applications integrate with the bridge. There is one other aspect that I mentioned called a channel, and you can see in some of these transactions, a channel ID is being provided. And essentially that is because our bridge supports multiple different channels and kinds of communication. I mentioned earlier in the presentation that there may be some relays we run ourselves that are incentivized, that have kind of higher UX and guarantees and kind of automated, but that it's fully permissionless, and an end user may want to really just submit messages themselves. And so that's what the channels allow for. They allow for kind of a channel for incentivized relaying. There's a channel for kind of relaying that's basic, that any user can kind of relay their own messages in. And so the kind of applications should support multiple channels in order to remain permissionless. And so, yeah, and so kind of this is next up like an overview of where we're at. So we've got this evolving MVP. We have fully completed the MVP, and we have full two-way messaging, asset transfer, and arbitrary state support for our bridge. And we have that running in a kind of local testnet. Our trust minimization is almost complete. The Ethereum Lifelines on Polkadot is actually done. I can update that. And our Polkadot Lifelines is mostly done. We've got less than a month to go on our expected plan, because we're just adding one or two more verifications that need to be done, as you saw what was missing in that palette. And then for interaction with other parachains, we're adding XCMP APIs. So if you're not familiar with Polkadot, essentially Polkadot has multiple parachains. And what I showed you now was an application running on our parachain, but there will be applications running on other Polkadot parachains that want to interact with Ethereum. And so we have cross-chain messaging APIs to essentially allow palettes and modules and even kind of Solidity smart contracts that will run on other parachains to interact with our bridge in the exact same way that I've just shown you. And so these APIs will be ready in 1 to 2 months. And so if you look at our overall timeline, today we have our MVP working on a private testnet. Our palettes and our code base and smart contracts are all open source and being reviewed. Early mid-June, which is next month, we expect the fully trustless MVP to be complete. Late June next month, we should have a public testnet launch that we try launch to, and other people will start to be able to use the bridge, test it out, and start to kind of interact with it and integrate with it. And then we're hoping that with the Polkadot parachain launch, as soon as Polkadot actually launches support for parachains, we'll be production ready and we'll be launching as a system parachain soon after the Polkadot parachain launch, which, that could take a few weeks, could take a few months. We're waiting on the core Polkadot teams and community to confirm that launch date. But if you've been paying attention, you'll see the Kusama launch is coming up really soon. We do also have a plan for deployment on Kusama, and that's still being finalized, but we'll have more to share on that soon. And so kind of that's my presentation. Some links if you're interested. If you're interested in Snowfork and kind of our group and community, here's Snowfork's website. Snowbridge, we've got a small website set up, which we're still iterating on, which has all of the details I've talked about, and an overview of the project. Our documentation, Snowbridge docs, are kind of a work in progress, but they're public now, and they contain a lot more details around kind of the architecture, more details of how things work below the hood on the bridge, and details of these applications that I mentioned to you. So if anyone's interested, I'd recommend going through these docs. I'll get GitHub repos linked here, and we expect soon to have tutorials and integration guides coming soon. And if you're interested, you can join our mailing list, snowfork.substack.com, where we post occasional updates, and we'll be rolling out when we release our finalized MVP version of the code and our testnet. If you sign up, you'll get notified there. Other than that, feel free to check out these links and get in touch if you're interested in helping out with the project or integrating as a user of the bridge, whether you're an Ethereum application or a Polkadot application. And yeah, that kind of ends my presentation. Thanks everyone for watching, and looking forward to how people kind of play with this in future once it's ready.
Aidan, thanks a lot for this presentation. If you can send me the link to the deck, I'll make sure to include all the links in the video description so they are clickable. And yeah, I think that should help the viewers a lot.
Yeah, I will do. Thanks a lot. We'll do that.
Yeah, so I'm really excited to see your product, the public launch. Yeah, congratulations. It's really impressive.
Yeah, thanks. We're looking forward to it. I think hopefully next month we'll have it all ready for everyone to play with.
Fingers crossed. Yeah, Aidan, thank you very much for your time. We're gonna have a discussion panel in around 30 minutes. So for everyone watching, stay tuned. And Aidan, thank you again for your time.
Cool. Thanks, everyone. Bye.